Okay, here are some more questions for you, this time about field strength that we just covered. So have a really good read through these questions, attempt each one as best you can, and then watch the rest of the video as I go through the answers. So pause now. Okay, hopefully you paused then and had a good go at these. Let's go through the answers. So, an object of mass 100 kilos rests on the surface of the moon. If the G, I should say if G, the gravitational field strength equals 1.6 newtons per kilogram, what is the gravitational force acting on the object? Well, gravitational field strength is force per unit mass. So force is going to be gravitational field strength times mass, which is 1.6 newtons per kilogram times 100 kilos, which should be 160 newtons, which is significantly less than it would be on the surface of the Earth. Right, question 2. An electron passes through a uniform electric field and experiences a force of 8 times 10 to the minus 15 newtons. What is the field strength? Well, the electric field strength, which is capital E, is the force, this time not per unit mass, but per unit charge. So that's going to be Q. So it's going to be the force 8 times 10 to the minus 15 newtons divided by the charge of the electron, 1.6 times 10 to the minus 19 coulombs, which gives you 8 times 10 to the minus 15 divided by 1.6 times 10 to the minus 19, 50,000 newtons per coulomb, 5 times 10 to the 4 newtons per coulomb. Right. Question 3. Sketch the path of an electron moving through this field. Well, this is a uniform field. First of all, the electron, obviously, let's have a look. You know, we could just think that the electron's negative, so it's going to be repelled away from the negative plate, and it's going to be attracted towards the positive plate. So it's probably going to do something. I'll just draw it. It's probably going to do. I'll draw another electron that I can move easily. It's probably going to do something like this. Maybe it will hit the electrode. Maybe it will escape. But it's going to do something whereby it moves towards the positive and away from the negative. So if you've done anything like that, well, that's good. We can go a little further though and just think about exactly what the path is going to be like. Now we've just worked out the force on an electron in a uniform field, and that depended on. Well, sorry, we've worked out the field strength. We had a force acting on an electron in a field. Now, because the field is uniform, that force is going to be the same everywhere in the field. Now, that might sound familiar. That's kind of a bit like an object being chucked on Earth in a gravitational field, in that the force on the object is the same the whole time. It's its weight acting vertically downwards. So in this case, there's going to be a force acting on the electron. It's going to be the same force the whole time because it's a uniform field, and in this case it's going to be vertically upwards because of the arrangement. So the path it follows is therefore going to be the same shape as the path that an object chucked horizontally on Earth follows, and that is a parabola. Okay, so give yourself a bonus mark if your shape looks something like a parabola rather than, let's say, a quarter of a circle or something like that. It's hard to judge whether something's a parabola or not, but it's just nice to know that that's what the shape of it would actually be. So hopefully again those questions have been useful.